Okay. So this first chapter that we're going to look at, the first chapter and especially this first section is very, very heavy in terminology. All right. Now these terms are also defined in your textbook. Okay. But we're going to go over what they mean. Most of the chapters that we cover after chapter 1 are not nearly this vocab intense, right? So we're just really kind of setting up our language so that we have an understanding as we move forward through the rest of the semester. So when we think of statistics, all right, statistics is in fact a science, all right? And in that science, we do things like collect, organize, summarize, and analyze information, ultimately to be able to draw conclusions, all right, or answer some sort of question that we're looking at, okay? Now, when we also think about statistics, one of the other things that we want to consider is we want to be able to, through this analyzation or analyzing the information, we want to be able to provide some sort of measure of confidence in the conclusion that we're making. That's kind of the general gist behind it. So one of the terms that we're going to need to consider here is data, right? You all probably know already what data is. We are going to define data as characteristics of an individual item. In other words, when we get to it, it's kind of like we're defining our variables, if you want to consider it that way. Data are fact or propositions used to draw a conclusion or make a decision, but ultimately we want to know that in the data that we're looking at, if we want to understand what data is, we define data as the characteristics of an individual. Now, data becomes very important for us in statistics because in order for us to be able to answer a question, there has to be variability about what I expect to have happen when I'm looking at this data. So for example, we can look around the room and we know intuitively that we're not all the same height, are we? So I could say that height would be considered data, right? That I'm looking at, in other words, and there's variability in our height, which is going to be interesting if I was looking at a question about height, okay? Questions are not interesting if there's only one answer to that question, okay? So variability in our data is important. The goal of statistics is to be able to describe and understand the sources of that variability. Okay. So height was an example of data that I described earlier. Cars are examples of data. Gender, age, all of those types of things. Those are characteristics of an individual that we might want to look at. Now, the next thing we want to think about, the next term we're going to look at here, and we will continuously be using these ideas here. We want to think about population. We define a population as everything that belongs in the group you're looking at, right? And we'll see how that's important in a minute. But the population has to do with everything in that group that we are interested in studying, okay? And if I think about it, I could say that if I was interested in the population of students, all students enrolled in statistics at MCC, I could define that as a population. All students enrolled in statistics at MCC, okay? Now, it's not always feasible, and in statistics, this is what we're kind of looking at. It's not always feasible to be able to go out and talk to everybody or look at everything in a particular population. MCC's got a fairly small enrollment, so it might be feasible for us to go out and talk to every MCC student who's enrolled in statistics. That could probably happen. Might take some time, it might be a little labor intensive, but it could happen. If I were to maybe go grander and say, maybe I'm interested in the population of students taking statistics in any Texas college, right? Any Texas, that would be kind of larger, wouldn't it? That would not be something that would be feasible to be able to go in and talk to everybody from that population. Okay, so because of that, in statistics, we take a sample. So a sample is defined as that subset of the population, okay? Now let's bring our population back down to the example that I have up here on the board. That population being all MCC students that are enrolled in statistics. If I think about a sample, you all would be considered a sample of that population because you are also taking statistics. You're here at MCC and you are a subset of that population. Okay? Understand that term? Okay. Now, in order to be able to describe the population, we have another term which we call a parameter. So a parameter is used to be able to describe our population. Parameter, population, do you hear that alliteration right there? Okay, that's one way to remember that the two go together. So a parameter describes the population, and we use that to describe the population. For a sample, we call it a statistic. So if we want to describe something about the sample, okay, we use a statistic to describe the sample. Again, we've got the alliteration going on there. So population and parameter go together, sample and statistic go together. They both start with the same letter. Okay, now we'll see what that looks like in just a second. But another term we want to consider is a census. Does anybody know when we last had a census? 2020. And how often do we do a census? Every 10 years. That's right. Why do you suppose we only do it every 10 years?
It's hard to get everyone to take the census.
Because it's hard to get all of the people, because this is a collecting information from everybody in the United States, right? Everybody in the United States, not just a group, right? Everybody there. And it's hard to do that. Why else do you think we only do it every 10 years? It's expensive, it's probably labor intensive, right? And all sorts of reasons why you couldn't do it all the time. But a census is when we collect information from every member of the population. Okay, let's look at this example here. Suppose that the percentage of all students on your campus who own a car is 48.2%. All right. Now, if I wanted to identify whether or not 48.2% is a parameter or a statistic, remember, a parameter is going to describe what? Population, and a statistic describes what? Okay, so we want to try to determine from this sentence here, is 48.2% describing the population, or is it describing a sample? Population, that's right. What made you think it was the population? It says all students, right? Does everybody see that up there? So you're going to find that when we're looking at our statistics and that reading that we're going to be doing, we want to try to use context clues to be able to identify, you know, and answer a question. So yeah, the all students part of that gave it away that this was a population. That value, 48.2%, represents the parameter, okay? Because it's a numerical number that's describing the population. That's what we're looking for here. Let's look at this one. Suppose a sample of 100 students is obtained, and from this sample, we find that 46% own a car. Is that a parameter or a statistic? And what gave it away? The word sample in there, right? It's not always that clear, okay? Sometimes it is, and that's what you want to look for, all right? Another way they could have said that is they could have said, suppose 100 students from the MCC were asked who owns a car, and 46% of them did, something like that. If you're given kind of a number out of a total, even though you don't know the total, then again, that would be an indication, a context clue that you're talking about a statistic, that you're talking about a sample. You're describing the sample. So that value represents the sample or the that value represents the statistics because it's describing the sample, okay? All right, so we now know population and parameter, okay? We also know sample and statistic. The next thing we want to talk about are descriptive statistics and inferential statistics. So when we think of descriptive statistics, we want to think of these things as a way to be able to describe, okay, a way to be able to describe our data. This is what we focus on in the first 3 to 4 chapters of the text. We describe our statistics. Remember, we're describing information about a sample that way. We will describe our statistic through numerical summaries, think mean, median, and mode, tables, and graphs. What type of graphs can you think of for describing statistics or describing things? Pie chart, bar graph, right? There's a time plot that could also be done that way. So graphical displays is what we're looking at there. That's the first part of our course. And then we move into inferential statistics after that. So inferential statistics is where we're going to take that information from the sample and infer it onto the population and measure the reliability of that result, all right? So the first part is descriptive, the second part is inferential. Now, for this next screen, I'm going to go kind of fast. Again, these terms can be followed up by getting the whole thing out of the textbook. But for this next one, let's talk about that process of statistics. There's going to be 4 areas that we describe, and it's going to re-emphasize what we just talked about. The process of statistics starts by identifying some sort of research objective, right? You got to ask a question, right? What do you want to look at? What do you want to try to understand? Okay. And then you also want to make sure in that research objective that you are identifying that population that you want to be able to answer the question about. Okay. So that's going to be our research objective, identifying that research objective. The next thing would be, I want to be able to collect the data. So once I figure out my question and who I'm going to be taking this or answering this question about, I've got to go out and collect the data. To collect the data, there's all sorts of different sampling methods we're going to look at tomorrow or Thursday, I suppose. Okay, but in this collection of the data, it kind of ends up being an important step in your process, because if you don't collect the data in the correct way, let's say, it can actually negate your conclusion, right? There was a paper or there was information, an article I think I was reading a couple of months ago talking about a study that had been done, and because the collection of the data wasn't done, it was biased in a way, it threw into doubt the conclusions that were made from the study that this paper was publishing. The third thing in this process has to do with being able to describe the data. Well, that was our definition that we just had a minute ago. So we get a question, we understand who we're going to put this question to, what the population is. We collect the data about that question, and then we've got to go ahead and describe the data through our tables, summaries, and our graphs, okay? We want to be able to give that overview of what it was that happened in our sample that we just took. Finally, we have our inference, okay? And like I said, the inference part of this, all right, where we are trying to find through some level of reliability, making some inference onto the population there, that's things that we're going to do later on, starting in chapters 5 through the end of the book, 5 through 10 in essence, all right, are going to set us up for that. So there's 4 steps to this process. What does that look like to y'all? Does it look familiar? Looks like the scientific method, right? Okay, 4 steps for the scientific method makes kind of sense, and statistics is considered a science. All right. All right, very good. Now, let's see if we can kind of identify this in an example that I want to look at. So here we have the an example about gun control. And it says that the AP National Constitution Center conducted a national poll to learn how adult Americans feel about existing gun laws and if they infringe on the Second Amendment to the Constitution. So that first step that we're supposed to ask in the process was what? What's the first step?
Identify research objectives.
All right, identify a research objective. All right, so what did they do? Well, they wanted to determine the percentage of adult Americans who believe gun control laws infringe on the public's right to bear arms. So you've got a question that's being answered, and they also identified with from whom they were going to try to answer this question about the adult population of the adult Americans. All right. The second thing that we want to look at in that process was what? All right, collect the data. So if there are, at the time of this question, if there were 200 million adult Americans, right, it's not real feasible to go out and talk to all of them. So instead, what they did is they took a sample of adult Americans, all right? They sampled 1,007 adult Americans and found that 514 stated that they believe gun control laws infringe on their right to bear arms, okay? One of the things that I always found interesting when I first started teaching statistics again was, does anybody want to know, or was anybody curious, why on earth did they choose 1,007 adults? Have you ever seen polls that they put up on the news or whatever, and it'll tell the sample size, and it's never like 1,000 or it's a little bit different than that. There's actually a mathematical formula. There's a science to how large of a sample size I need to have in order to get the results with that reliability, that confidence, right? And it's never going to be that nice little perfect 1,000, 2,000 or whatever. I always thought that was kind of interesting. So there is a reason why it's 1,007. It's not just some random number somebody pulled out of a hat. What's the third thing that we want to look at in this process? All right, we want to describe the data. Remember, when we describe the data, that is to be able to summarize the information about our sample. We don't know anything about the population yet. We only know information about the sample. We have a question about the population, but we're only looking at the sample. So that summary is that 51%. Remember, that is considered a statistic that's describing the sample of 1,007 people. And they found that 51% believe that gun control laws infringe on their right to bear arms. All right. Now, the 51% came from that ratio, right? That proportion of, or that fraction of 514 out of 1,007. Okay. And that's one of the ways that we would say we have descriptive statistics. It's summarizing the data from that sample. What's the last thing that we have in that process? Inference, right? So now that we have information on the sample, those 1,000 people, we got to make some conclusion on that adult population. Researchers wanted to extend the results of the survey to adult Americans. And when generalizing from the sample, those results are uncertain. Why do you suppose they're uncertain? Well, that's true. That's true. I like that part. I was thinking more, I was going in a different direction. Why might there be some uncertainty to this? If there's 2 million people that they're talking about as far as adult Americans, and they chose 1,007, what if they repeated the study and this time they got a different 1,007, right?
It's too small of a sample.
It's not too small. I know it. I always thought that too. It's not. It's really weird, but it's not. With some level of confidence, which is later on, but it's not too small. Too small would be like 20.
It also could change where in geographic places you ask, like, yes, Texas compared to California could change quite a bit.
That has to do with making sure that the sample you collected was not biased, right? An unintended bias that can happen, okay? The idea that when you have a sample and you have a confidence interval or a level of confidence, or maybe another way to put it would be that margin of error. How many times have you seen a poll put up or a statistic put up on the news or somewhere in a newspaper? They'll give the statistic, but they'll also give that margin of error, right? So in this particular case, they found that there was a 3% margin of error. I always think of that as kind of like a wiggle room, but what it really has to do more with is if I were to repeat the study of 1,007 people, sampling different 1,007 people, we're fairly confident, 95% confident, that if I were to repeat it, that percentage of, or that fractional amount of people that believed it infringed on their rights is going to be somewhere between 48 and 54%. That's what the margin of error says. We don't really ever know what the true number is. Remember, it's kind of an inference. We're kind of making a best guess on what we think the true population believes. And we do that with a level of confidence and a margin of error, because we know that there's going to be error in there because it's a variable and there's always variation, right? So this is kind of an overview almost of how we're going to be, what we're going to be looking at in the course even, where we talk about specifically step number 3, organizing, describing, and summarizing the data. And then in the later part of the course, really happens more about chapters 8, 9, and 10. We get into the really big crux of making that inference onto making the conclusion. Okay? All right. Now, in order to be able to perform our study, we have variables, right? So we are going to define our variables in 2 ways. So we all kind of, I think, intuitively know what a variable is. It's something that's going to be changing. In this particular way, we would identify the variable as the characteristics of those individuals from the population. In other words, it's the data, right? Now, I'm not too interested in that definition. What I'm more interested in is the definitions I'm going to put up here, okay? I'm going to hand out a piece of paper also that might help organize these last concepts that we're working on. This is typical of the type of handout that I'll be giving in class. It's kind of like hitting the highlights for the section that we're covering, kind of the important information. Thank you. So we have qualitative, or another term would be categorical variables. Now, your textbook is going to identify this type of variable as qualitative. I put up there that it's also seen as categorical, all right? That's synonymous for this variable. I'll sometimes default to categorical because it can get kind of I get tongue-tied talking about this. But in other words, a qualitative variable is going to be something that allows me to classify or put into some category what I'm looking at. In other words, I want to categorize it based on its attribute or some characteristic. So qualitative or categorical variables are things that I can put in a category. It's the reason I call them categorical. One example of categorical or qualitative variables might be hair color, right? Marital status. Okay. Can you think of other qualitative variables? Gender.
Sexual orientation.
Sexual orientation. Religion. Race, right? You get the idea here? Okay. some sort of attribute or characteristic. Now, the second type of variable, so there's only two. There's qualitative and quantitative. So quantity, something that I can measure, okay? Values of quantitative, it provides numerical measures of that individual or numerical measures of the data. Now, these numerical measures have to have meaningful mathematical application, all right? So you're not just looking at a number. It's not enough for it to be a number, but does that number have meaning? Can I add it? Can I subtract it? Okay, can I take the average of it? Something like that. It has to have mathematical meaning. Typically, can we measure it? Is going to be an idea to think of when you're talking about quantitative. All right. So let's look at it, a couple of examples for that. So quantitative variables, I'm interested in numerical measure. Can I add it or subtract it? Qualitative variables are categorical. Can I classify them based on attributes? All right, so let's look at these 4 examples here. We want to determine whether they're qualitative or quantitative. What do we think gender to be? Qualitative? Yeah? Okay. Yep, I would agree. How about temperature? Quantitative? Okay. The number of days during the past week that a college student studied? Quantitative. Your zip code? Qualitative. Qualitative, right? Now, your zip code is a set of numbers, right? But what do those numbers really identify? Your location, right? There's no mathematical meaning to your zip code, is there? Okay, so even though it is a number, even though your zip code is a set of numbers, just like your social security number, let's say, that number has no mathematical meaning. So it is simply identifying your location in the county, I think, right? Okay, so don't fall for just because it's a number, it's going to automatically go into quantitative. That number has to have meaning, right? Quantitative variables are numeric measures such that meaningful arithmetic operations can be performed on the values of that variable. Again, can I add, subtract, take the average? Qualitative describes some attribute, okay? Now, if there's 2 variables that we're looking at, qualitative and quantitative, all right, we can take quantitative variables and break them down just a little bit further, all right? Not qualitative, but quantitative variables can be broken down just a little bit further, okay? We break them down into what we call discrete and continuous variables. So a discrete variable is basically just something that you can count. Think about counting on your fingers, all right? Think about integer values, if you want to think of it from a math term, all right? Think about it as an integer value in essence, all right? When we think about quantitative variables, there's a finite number of values. A visualization of that might be if I were to plot points on a graph that represented the data that I collected, right? That would be discrete variables, okay? Your shoe size is considered a discrete variable. There's a finite number of shoe sizes, right? Okay, whether you're talking about maybe just whole shoe sizes or whole and half shoe sizes. That's it. Those are the options. There's no more. Okay. Continuous variables. There's an infinite number of possibilities on that one. All right. So if I go back to my graphical, visualization here, remember we had discrete variables, which would be individual points. Continuous variables would be that straight line. There's infinite number of points on a line. That's considered continuous. Okay? Your weight, blood pressure, temperature, all those things would be considered continuous. Typically, if we can measure it, you're kind of considering it to be continuous. Okay? So we have two variables, quantitative and qualitative. Quantitative variable is the one that gets to split into two with continuous and discrete. Ultimately, past chapter 1, this chapter that we're in right now, we're not really going to have to break down that quantitative variable and understand it too much into discrete versus continuous. We do spend a little bit more time identifying qualitative and quantitative because we actually handle them differently in the way that we display them and some of the application or some of the statistical processes that we use and the formulas that we use in essence. They get a little bit different treatment, quantitative versus qualitative. Discrete and continuous is just kind of a extra little know-how. So let's practice these three ideas right here, okay? We want to identify these as either discrete or continuous. So if I was thinking about the number of times, the number of heads obtained after flipping a coin 5 times, what would we consider that? Discrete or continuous? All right, I would agree. I can count them, right, on my hand. The number of cars that arrive at McDonald's between 12 and 1 p.m. Discrete, I can count them on my hand, right? Okay. I pushed it too soon. The distance that your car can travel in a city during conditions of a full tank, that can change all the time, right? Okay, you can measure that in essence, can't you? Okay, so that would be considered a continuous variable. Okay, so a variable is discrete if it results from counting. A variable is continuous if its value is measured. All right, are there questions on that terminology so far? All right, so in the remaining 10 or 15 minutes that we have, we're going to practice the questions that I have on your paper that I handed out to you. And typically when we're in here, I really find that there's a lot of value in discussing these problems. If you come up with an answer, do the people around you agree with that answer? Verbalizing why you think something is one way or the other in statistics is extremely important. So we're going to do a lot of group work, table work, all those kinds of things. So what I want you to do is you're going to answer through question number 5, which is on the back, 1 through 5 with some people that are around you. So I want you to just get with groups of 2 or 3 people around you. That can be front and back. All right. What I want you to do in your groups, I want you to introduce yourself. All right. Give each other your name and your major. And I will be walking around to meet you, find out what your major is, practice your names, right? Okay, so groups of 2 and 3, front and back, that idea right there. Slide around. There, okay, you can be side by side, okay? You can go to the side, y'all can go side over here.
No. Awesome.